We discussed up to 7th. 7th. Uh, right. What is the approximate percentage by volume of nitrogen in the atmosphere? Right. So it is around 78%. Right. So the answer was B. Right. So I think we have discussed that day. Complete the dot cross diagram of a molecule of nitrogen. Show the outer electrons only. Right. So nitrogen. Um, each nitrogen atom has 7 electrons in the valence shell, and between them they can make 3 bonds. So lone pair, 2 electrons each, and you have to mark it with a cross and a dot. Right. So nearby two atoms who are making the bond must have two different symbols. Otherwise, we don't know these electrons are belong to which atom. We are not aware of it. Three bonds are made. So now three bonds are made by sharing electron each. Right. One, two, three. Right. And the thing is, to make it more clearer, we must show the boundary now. This is the boundary of this. And now these six electrons are within the boundary of both the atoms. Right. So this is the uh, appropriate way of doing it. Right. And remember, this process must be within the boundary, right? Because they are not being part of the bond. So they must be within the boundary, on the boundary itself, on the border itself, like this. Nitrogen dioxide produced in a car engines react with water vapor and oxygen in the atmosphere to form nitric acid. Right? Nitric means HNO3 acid. Give a chemical equation for this reaction. So you have to write the chemical equation. The reactants are also given. Nitrogen dioxide, water vapor. Water vapor means H2O gas, right? Nitric acid, right? Two hydrogens are there, so you have to balance it. But remember, now later you guys are learning these are oxidation reduction reactions. So NO2 with water only, HNO3 is not made. Right? So you need what? NO2 also. Later you will learn NO2 is getting O2, sorry, O2 is getting reduced. So now let's see. Now 2 HNO3, so let's my like 2 here. Uh, Two water molecules. So 4 HNO3, So 2, 2, 4, 2, 6. So you have 4, 9, no 2, no 3. So later finally we'll balance this number of oxygen. So you have here 12, 10, 12, right? It is all balanced. Okay. So remember, it comes with practice. So as per this equation, so since you have only one element in oxygen, so you can let it balance later. So you can start off with the others and later finally by counting the remaining atoms, you can put a number in front. The coefficient value you can decide. The coefficient you can decide on that. Right? You can leave it for later. Nitric acid forms acid rain. State the environmental effect on acid rain. You can write many things, right? So when the pH is going down in the water bodies, flora and fauna, it is harmful. The pH may go down, and also for man-made objects, for example, calcium carbonate, right? The monuments made out of calcium carbonate will get what? Will get damaged. Things like that you can write. Right? But the main thing is uh, the impact of acid rain on the flora and fauna, plants, and deforestation. So as a result of that, you have deforestation and so on. Ammonium carbonate contains nitrogen. What is the formula of ammonium carbonate? Ammonium carbonate is made of as NH4 plus. Carbonate is CO3 2 minus. You know, if it is an ion, the valency means number of electrons that are being shared, removed, or taken. It is equal to the charge. If it is an ion, so this is a molecular ion. Here the valence is plus 1. So you swap it. So when you swap it, it must be within the brackets to tell the whole molecule must be multiplied by 2. Here carbon is by 1. So usually when you have 1, we don't show it. So it must be NH4 twice carbonate. Right? And the ammonium is NH4 plus, not NH3. It is ammonia. Ammonia is the molecule. Ammonium is the ion, NH4 plus. So NH4, this is the answer, right? A technician finds an umbrella bottle on a shelf that could be ammonium carbonate solution. A technician finds an unlabeled bottle on a shelf that could be ammonium carbonate solution. Describe the test the technician should do to confirm that the solution contains ammonium ions and carbonate ions. Right? So, ammonium and carbonate means and CO3 2 minus CO3. So with this you can actually release what? Ammonia gas. And from the other end you can release the carbon dioxide gas. Right? But but you have to test it separately. Right? Because ammonium is, this ion is acidic. Carbonate ion is, right, this ion, when you add uh, Acid, you can release it. Right? Alkaline, right? Uh, right. So therefore, to release carbon dioxide, you can add, since it is alkaline, you can add a acid. Since this is acidic, to release this, you can add what? An alkaline. So separately, you take two separate mixtures. Alkali means sodium hydroxide heat. Acid means you can add HCl and heat. Right? So therefore, when you add HCl, so these are two different experiments. Carbon dioxide gas is released. You know how to identify carbon dioxide gas? Lime water change the color. Lime water becomes white. Right? Uh, yes, lime water tells milky color. So 3 points are there for that. In a separate experiment, you are adding sodium hydroxide and heat. Ammonia gas is released. How do you know ammonia gas is released? You wet litmus paper. You hold a wet litmus paper on a glass rod. Wet litmus turn what color? Which color? Red color to blue color. Right? Red litmus into blue color. Right? So those are the tests. So you are getting 6 marks each. Okay. This this question is about hydrocarbons. Molecular formula represents all the isomers of alkenes. What is an isomer? Tell me. Huh? Same molecular formula but different uh, structural or displaced formula. Right. So this is the molecular formula. Using this, you should be able to make two different structures. Right? And they have tell you, and it must be an alkene. Alkene must there must be a double bond in between. Right? So what you can do? Isomer, the definition they ask, same molecular formula, different structural formula or displaced form. That is the definition. Right? So you get it 2 points, mentioning as same molecular formula 1 mark, different structural or displaced formula the second mark, 2 marks together. Right? Displaced formula of one of isomers of the alkene is shown. Draw the displaced formula for two other alkenes isomers with the molecular formula C4H8. Alkene and alkene isomer 1 and 2 is given. Displaced formula. Displaced formula means something like this. All the bonds must be mentioned. Easy peasy, right? Other two alkenes. So what you can do, you can bring this double bond to here. Bring to here. Uh, you can complete the hard. So this is how you start sketching the diagrams. Always start with the carbon skeleton and then complete the number of four bonds. Adding hydrogens and completing the diagram. And the other one is if someone tells you, is this the isomer of this? What do you think? Could this be the isomer? Or the same molecule? Is it the isomer or the same molecule? What do you say? Yeah, this is the same molecule. These are the same. You just twist it, turn it the other way. It's the same molecule, right? So this is not an isomer. But what if we branch it? We break it from here and plug it here. What will happen then? Then it is an isomer, right? Okay, okay, okay. And these two are isomers. See, same number of carbon, same number of hydrogens. Okay. Here also you must complete the hydrogens, right? The correct number of bonds. Since they have double bond, you need only what now? Two hydrogens here. Yep. Plug in the hydrogens and see. Next one. Right. But1 reacts with bromine to form a compound with molecular formula C4H8Br2. What is the name given to this type of reaction? But1 reacts with bromine to form a compound with molecular formula C4H8Br2. What is the name given to this type of reaction? Okay, So you know but one name is this the formula we have discussed before, and you have another two BRs now. So you have added another two, right? It's an addition therefore, right? Addition. Combustion means you must release carbon dioxide, oxidizing it. Decomposition means you have to break it. Substitution means you have to replace an atom with another atom, different atom. Here you have added Br, right? Here, remember, you have converted it to this. The double bond is becoming a single bond, and you become made it to this. It's an addition, another addition of atoms. So it's called addition reactions, right? Right. The alkene can be polymerized to form polymer, polypropene. Draw the repeat unit of polypropene, right? Polypropene means polymerize. Many. Prop means three carbons. One, two, three. When this is polymerized, right? When it is getting polymerized, this double bond is broken and it becomes a single bond. Draw the repeating unit of polypropene, right? So it's like this. So we had this one. This is propene. You don't need to learn how it is getting polymerized, but for your understanding, I will tell you when two of these are getting polymerized, what happens here. Right? At your level, you don't need to learn this, right? At your level, not needed. So these two are, for now, just say they are getting connected. So when they are getting connected, this is the new bond formed, right? And remember, they are connecting with the other neighboring similar molecules the same way. So you have to think of the back end also, right? From the back end also it is attacking. It is connected with the other similar molecule. But you must remember the sequence, right? Same sequence must be maintained, right? Here also same sequence. Sequence must be maintained. CH3, hydrogen, double bond into single bond, hydrogen, hydrogen, right. So this is being polymerized. Repeating unit means you must look at the pattern. So same unit is being repeated. See, one, two. Here also same unit. So since it is repeating, this is the repeating unit, and it can get polymerized into n number of times. as many as you like. But remember, this one must be here. You must show, right? You must show this carbon is connected to the other neighboring carbon from the back end and front end. Otherwise, your answer is wrong. So this one must go beyond the bracket, right? So if you are doing it right, uh, this is the perfect answer. Even at A level, this is the correct one, right? So this one must go beyond the bracket, right? Now it is correct. N number of times. This is the repeating unit. Okay. Make sure to have the bond beyond the box, right? Or the box brackets. Okay. Polypropylene, right? Here, prop. Previously, it was a propene. Polypropylene, many propenes polymerized, right? This is the perfect answer. Any questions from here, guys? All good. These two methods for disposing of polymers such as polypropylene. Method 1, burying them in landfill sites, burning them to release heat energy. State one environmental problem to each link to each of these methods of disposal. Method 1, if you are burying it, what will happen? It is not getting decomposed. So the decomposition is very slow, right? You will run out of space, right? Uh, okay, burying them in landfill means running out of space, right? The landfill will get what? Overcrowded with the decomposable material. You are running out of land, of space, or land, because it is not getting decomposed. So you will have to find another land for the landfills. But if you are using decomposable material, you will not have that problem. Why? In few years, it is getting decomposed. You can again use the same site to dump all the material in. Method 2, burying them to release heat energy. What will happen? It will cause what? Release carbon dioxide and cause greenhouse effect. It will, one major thing is what? Global warming. It will contribute to global warming. And also, it may release toxic and acidic gases that will harm the environment straight away. So you can tell, these are not sciences even, like the social sciences. You can even think and write. Complete combustion of one molecule of alkane produce 396 grams of carbon dioxide, 180 grams of water. This is the equation for the reaction. Give me a second. Right. Right. Complete the combustion of 1 mole of alkane produces 396 grams of carbon dioxide and 180 grams of water. What is the equation for the reaction? This is the equation for the reaction. Calculate the values of x, y, and z. Ah, okay, okay. So they have given the total mass as also, right? 396 of carbon dioxide, 180 of water. So let's find the number of moles of each of these. So carbon dioxide 44 divided by 44. Here it is 18. So when you do that, you are getting it as 10. Here you are getting it as 44. 9, right? Yes, 9. So it is 9 to 10, right? So if it is 9 to 10, now remember, since it's an alkane, alkane does not contain any oxygen. So all the oxygen here is coming from what? From the oxygen gas. So therefore, number of oxygen atoms here what? 18, 9 times 2 plus 10, 28. So therefore 14, this must be 14 by 14 times 2, right? So it must be 14. 9 to 10 to 14, right? So that's the ratios between these, right? And it says 1 mole of alkane. 1 mole of alkane means 1 mole of alkane means using 14 moles of oxygen and producing 9 moles of carbon dioxide and 10 moles of water. Right? So it is all done by 1 mole of alkanes. Right? 14 to 9 to 10. So that is the answer. Find the number of moles of each. Mass divided by molar mass gives you the number of moles of each. Right? You can use that to find the values with the answers. In a petrol engine, incomplete combustion occurs because there is a limited supply of oxygen. Petrol contains octane, C4H18. Complete the equation for this reaction, including the state symbols. Explain one problem for humans posed by a product of this incomplete combustion. Incomplete combustion means uh, limited amount of oxygen is supplied. As a result, it is not combusted, it is not getting oxidized completely. So as a result, you are not getting carbon dioxide, you are getting carbon means soot, or may either you are getting carbon or either you are getting carbon monoxide or both, but you are not getting carbon dioxide. To have carbon dioxide, you must have excess oxygen. So you are using only limited oxygen. So therefore, you are getting only carbon dioxide or carbon no soot or either both. Uh, explain complete the equations. So here they are. We need the states, right? Easy. Gas, carbon monoxide gas. Carbon is a solid. At room temperature, H2O is a liquid. Right? Keep that in mind. Yeah, the temperature is going up, therefore it becomes a gas. But we assume it is happening under room temperature, so therefore it is a liquid. Right? Uh, complete the equations. So it's much easier now when you look at hydrogens. This hydrogen, all the hydrogens are released to this water molecule. All the hydrogens. So it's easier if you can start balancing from there. Why all these hydrogens are here? 9 times 2. Uh, carbon, 3 carbons are here. So you have altogether 8 carbons. So all the remaining carbon must come from where? All the remaining carbon must go to this carbon. So therefore 3 carbons are here. 8 is total. 8 minus 3, you are getting 5 carbon atoms. Finally, you can go with this. If there is a molecule having made up with only one element, when you are balancing an equation, leave it for later, finally. Because it's what easier to balance, right? You can find the number of atoms and put a coefficient value here based on that. Now here, 5 carbons, 5 oxygens are released here, 5 oxygen atoms. 9 oxygen atoms are released here. So altogether 14 oxygen atoms are released. So all these 14 atoms are released from the oxygen. 14 atoms are contained in what? 7 oxygen molecules. 7 times 2 is 14. Right? That is how you balance it sufficiently fast. Right? Okay. Right. Explain one problem for humans caused by a product of this incomplete combustion. Right, one problem human means carbon monoxide is released. Carbon monoxide is a poisonous gas, right? So it may cause breathing difficulties, right? Carbon monoxide gas, uh, or you can tell that carbon monoxide. So that is the most important issue is that actually, right? Most severe issues. Or you can further explain carbon monoxide is limiting the capacity of human blood to carry oxygen. Right? That is called carbon monoxide poisoning. Right? So that is why we call it toxic. How it is toxic? by limiting the capacity of hemoglobin to carry oxygen in our blood, because all the carbon monoxide is irreversibly getting connected to hemoglobin in our blood. So therefore, there is no space for the oxygen to bind with our hemoglobin in the body, hemoglobin in the red blood cells. A student uses the apparatus to investigate the rate of reaction between marble chips and dilute hydrochloric acid. Rate means we are checking how fast the reaction is happening, how fast. Right? For that, we need to have balance, and of course, we need what a timer. Otherwise, we don't know how long it takes to stopwatch must be there. A student uses this apparatus to investigate the rate of reaction between marble chips and the dilute hydrochloric acid. This is the equation for the reaction: calcium carbonate, HCl, calcium chloride, H2O, carbon dioxide. During this reaction, the reading on the balance decreases because mass lost from the flask. State why mass is lost. Why? Carbon dioxide is is carbon dioxide gas, right? Carbon dioxide gas is released. Carbon dioxide gas has a mass. Even it is a gas, it has a mass. So that mass is lost. Assuming H2O, 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 H2O is also not being released, right? Because if H2O is released as a gas, then there will be issue. But at these conditions, H2O, let's assume nothing is getting released, it is still there, H2O liquid, right? Because this is a exothermic reaction, heat is released. So with that heat, this may get converted into H2O liquid into gas. So let us assume it is stays as that. So let us only focus on carbon dioxide gas, right? So definitely it is getting released. So that is why there is a weight change. Why? Because carbon dioxide gas is released out of the flask. That is why we have cotton wool to stop other from carbon dioxide from the atmosphere from coming in. Otherwise, the carbon dioxide from the atmosphere come and come again and from calcium bicarbonate. You don't need to think up that level, but that is why you have a bung with this. But still, carbon dioxide can come through, but from inside, carbon dioxide is released. So, because of that pressure, carbon dioxide from the atmosphere will not come inside. Right? So, you are learning that in diffusion, right? High concentration of carbon dioxide is inside. So, therefore, all the carbon dioxide will go out. That is why we are using cotton wool. So, you don't need to explain up to that level. Just say carbon dioxide is released as a gas from the flask, so therefore weight is decreased. State the purpose of the cotton wool. They have asked it, right? You can write this is a very violent, if it is a violent reaction, if it is bubbling, right? These bubbles may spill over. Calcium carbonate is a very nice reaction, right? Just like 7 Up, Sprite, Coca Cola. When you shake it, you see bubbles or foam is formed. So that like that, you can have some foam being formed, and if that foam goes off, it will affect the reading. Why you are losing more weight, not just only for carbon dioxide, because of spillover of also acids, right? The bubbles will, with the bubbles, it will spray out of the flask. To stop it from happening, you are using a cotton wool. Right. Mass lost. It is what happens later. It has become constant, right? Little by little, it has become constant. Explain the shape of the graph. You should assume that the marble chips are in excess. You have excess marble gas, marble chips. So it means you just write at the beginning what is the reaction, what is happening here in the middle, and what is happening here and why. Right? So you should explain these 3 points. In the beginning, the reaction is happening faster because there are more reactants in the mixture. And then at the end, reaction has come to a stop because of acid is limiting. All the acids are over because you have excess chips here. So chips are not running out. Acid is you are running out of acid. So until all the acid is over, the reaction is happening. So reaction has come to an end. That is why there is no loss in mass. Why? Acid is limiting. Therefore, until all the acids has come to an end, until all the acid concentration has come to an end, the reaction has occurred. And in between, why? The rate of reaction has decreased. Why? The concentration of the reactants are decreasing. When there's more concentration of the reactants, they are bumping onto each other, so the reaction is happening faster. When the concentration of the reactants are going down, the collisions are lower, so therefore the rate of reaction is lower. Right? So that is why any reaction is decreasing gently. At the beginning, the reaction is happening so fast. Can you see the gradient? See? Gradient. All the slope is equal to the rate of reaction. So here you have the higher grade, higher gradient, higher slope. Why? Because the reaction is happening faster. Greater gradient. Why? Because the reaction is happening faster. Reaction happens faster. That is why you have a greater gradient. So you can break into 4 points, right? Initial rate, final rate, in the middle, what is limited and what is in excess. On the grid, draw the curve you would expect to obtain if the student uses the same volume of hydrochloric acid but the half the concentration. Same volume, half the concentration. What will happen? Half the concentration means it's a limiting. You will got only half the volume of carbon dioxide. Loss in mass. This loss in mass. So half the concentration means half the concentration. Concentration multiplied by volume is number of moles. Half the concentration means half the moles. Half the moles means compared to previous experiment, only half of the reactant is reacting. So at the end of the first reaction, the loss in mass is equal to how much it has reacted. So this amount is reacted with full amount of acid. Now you are using half the amount of acid. Why half the amount? Because you are using half the concentration. Concentration into volume is equal to number of moles. Half the number of moles are used. So therefore only half of this is being reacted. So half of this in the middle, right? Okay, right. So it is at right at the half. Let's say here, and also reaction is also happening very slowly. Why? You have less number of molecules, half the reactant, so less collision. So therefore, gradient must be much lower, right? Since it's happening slowly, right? So you can't assume it to be the reaction to stop right at 12. It may stop maybe later, right? So we can't assume on that how long it will take to end the reaction. But remember, it will end at the half point here. Here you have 5.5, so it must be at the 2.7 at least. This is 12, so 12, so my bad. It must be something like this, half the amount. How long it will take to achieve this, you can't assume, you can't predict. It depends on the rate. But it is happening very slowly. You can't go like this. It means what? Reaction is happening faster. No, it is happening slowly because you are using half the concentration. Right? Okay, so something like this. It must start at the origin. See, yeah, it is always starting at 0, 0 point. The student repeats the experiment using the same mass of smaller marble chips. Explain using the marble chips collision theory how using the smaller marble chips would affect the rate of the reaction. Assume that all other conditions are kept the same as in the initial experiment. Small marble chips are what? Reacting faster. Why? Surface area. Surface area is increasing means reaction rate is greater. Why surface area is increasing the reaction rate? You have more collisions. Why? More area is exposed. So you have more collisions. So you had mentioned about smaller marble chips have higher surface area. Higher surface area have more collisions. Therefore, when not all other variables kept the same, the reaction is happening faster. Right? But if I ask you to do it on the scale, now they haven't ask that from us. If they ask us to draw the diagram on the chart, it would look like this. Same amount you are obtaining just because you are using smaller calcium carbonate, it doesn't mean you are going to get a higher yield. Same yield, you can get what you can get it earlier. Reaction is happening faster, a much higher gradient. It will stop over here. Reaction is happening faster. See? Happening faster, a greater slope, and the reaction stops earlier. Why? Because reaction is happening faster. At the end of the day, same amount of lost in mass. Why? Because the amount of chips are the same. Right? They haven't asked us. So I'll end it for today. We have only one question left. We will share another paper. So be ready and come. So that's all for today. Take care. Bye bye. Good night. See you.